So we are going to start first with two introductory speeches from Italian side, Dr. Campostrini, and from Slovenian side, Mojca Križ from Slovenian Ministry for Regional Development and European Cohesion. Dr. Campostrini, please, the floor is yours. You may share the screen now.
Good afternoon to everybody. Thank you to be here, and welcome to this first experience of this kind in the GreenHull project, which is substituting a physical event that should have been taken at the beginning of our project to launch our targets, our intention, and to say to everybody, good work. Let me say very few words concerning what is on my back side, the Interreg program Italia-Slovenia, which is a program, trans-border program, which for cooperation and instead for the cohesion. So the target is to get closer in the unique European Union. This is a program, a project within this program, which is dealing with maritime issues. And speaking about marine borders is like a contradiction of terms, because it's like an oxymoron, because the sea has no border. So, and this is also why we are here instead to try to find something which could be better for our sea, our common sea, between this small part of the Adriatic Sea in the northern part, but we believe that our result could be a bit, little contribution to the overall target of getting the sea better than it is today. In some sense, we cannot disregard the international frame where we are placed. We are in the last year of the preparation for the United Nations Decade of Ocean Science for Sustainable Development. So the science for supporting the development of sustainable use of ocean and seas. And I think that this project is a good example of this. And so how the technology can help the environment to stay better, can help the sea to be better. So we are not speaking simply of conservation of the natural, but we are speaking about sustainable use. So we see in our present, in our next future, that the sea resources must be used better, but used better than it was before. And in this webinar that we organize, we are going to speak about the technology, but also about the environment, why we are doing so. If Uros can allow me to show the first slide, which is the sense in a single slide, what we are trying to do in this 2 years project, is that we are trying to put in place to test and to some innovative green technology. We could mention them also blue technologies in some sense, because these are this work of green is more adapted to the terrestrial environment. In the sea, we use that we need innovative blue technology in order to allow the blue growth of our countries and our territories and our sea. We will have different kinds of technology. The first for cleaning the ship with biofouling, and but also to have this treatment of what we will clean, the material that we will collect should be treated before put again into the sea. And so in this sense, we will have a better use of the ships. The ships are necessary for us to connect each other and to make the better use of marine resources. But okay, we will test the best technology for a safer environment. So we are sure that we can achieve this kind of result. But this result will be ineffective without thinking about the legislation frame. because this kind of technology, okay, we will test whether they are possible and whether they are economic, whether they are useful, but they should be also allowed to be used. Otherwise, they will stay inside the paper, or simply inside a box inside our stores. And therefore, it is important that in this project, we will try to see the full frame of legislation. The full frame means that we are on the sea, as I said before. So we have to take into account that the sea is a matter of national legislation, sometimes also regional legislation, also European legislation is in some sense we have to cope with, but there are also a dominio which is international legislation, because the sea is the common path between the legislation corpus. There is also a very strong international convention which are obligatory. I do not mention here, so this will not be the focus of this first seminar, but it's just as introduction. It's good to know that we, in this project, we will have the complete frame, the complete feature of technology, environment, and legislation. These are at least our targets, and I'm strongly convinced that this will be also the possibility to realize what is in our mind. The project is very solid, as you will see really also today, we are the experts are good experts. We will reach this result in those frames that I mentioned before, for our regions, for our nations, for the Europe, but also for the whole United Nations, this small world where we are living in. Thank you very much for your attention, and we'll pass the floor to a more specific description of the project. Thank you very much.
Thank you, Dr. Compostrini, for a very nice overview of the project and for an optimistic view. Now it is my pleasure to welcome our guest from Slovenian Government Office for Development and European Cohesion Policy. Mojca Križ is Head of Sector of European Territorial Cooperation, and we look forward to your contribution.
Thank you very much for the word. Hello, everybody. I am very happy to participate in this kickoff meeting of the project. So to explain a bit what our office is doing, we are representing Slovenia in 4 cross-border cooperation programs, 5 trans-regional and 2 inter-regional programs. And Slovenia is also a member of 3 micro-regional strategies, where the Adriatic Ionic one is probably also interesting for the things that you are doing with your project, because it's tackling the same problems. So Slovenia is cooperating in the program Interreg Italy-Slovenia, the 5th generation. The first one was even before we were the member state. And within the program funds, we supported a lot of cross-border projects where a lot of scientific and the development institution is included. In this period, from the whole program, that is 70.77 million euro, we actually gave a part of the program funds to the specific objection 6F, what is the support of innovative technologies for improvement of the environmental preservation and the use of water. So what your project is actually tackling. And the lead partner, the International Schools of Josef Stefan, was successful in the 2nd public call for the standard project. Since this was the 2nd tried, we seen that a lot of work was done to prepare a good application, and we really hope that the project will manage to tackle the problems that they would like or that they expected in application. So we wish you all the best, and definitely we will keep in contact from our national point of view. Thank you.
Thank you very much for a very nice presentation and for good wishes. We will certainly stay in touch, and we expect a lot of good efforts from your office. And now we are moving forward to the main part of our today's webinar. Our Dean, Professor Milena Horvat, will present in more details the main idea of the GreenHull project. Professor Horvat is the Dean of Jožef Stefan International Postgraduate School and also head of the Environmental Department at Jožef Stefan Institute. And I see that she already has shared the screen. So we are looking forward to your presentation. I think we don't hear you.
Mute myself. Yes, I'm almost there. Just a second.
Excellent. So
yes, here I am. So thank you very much for organizing this webinar. I think it is a very interesting event because we talk about something that we all love: clean, beautiful sea with beautiful boats in there, and of course big boats that bring commodities to our northern part of the Adriatic. But of course such things bring with them also a number of things that need to be done and are not so environmentally friendly. We all know that boats, small, being small or big, they will always have something that will attach to the part of the boat that is in the water, because in the water there is the whole life, and everything that we have in the water will have something that will attach on it. And all of those people that are dealing with sailing know that every second year or every year even, you have to take the boat out and clean everything from this boat, and then put a lot of anti-fouling paints on this, and then put it back to water, because without cleaning the boats, this simply is not any pleasure anymore. But this is a pleasure stuff. But when we deal with something that is a big cross-Atlantic ship, you cannot simply take such a thing off the sea like a small boat and clean the bottom and then put it back to water. This is an extremely expensive stuff. Plus, when we have such things on the bottom of our boat, we can't really do the proper sailing, and movement in the water is very, very slow. So this is what this project is really dealing with. It is to develop in-water biofouling cleaning in the marine environment. What I have a great pleasure to be asked to present this on behalf of the whole consortium. You will see behind this project there are really enthusiastic people and partners that are eager to do some move towards this way. Myself, just to say, I am a sailor, and I've been on the sea for more than 30 years now, and I have to tell you, I have always wondered how we can do this better, and if we can make a step forward in this project, we will make a great, great contribution to the society, as our introductory talk said. Now, to go towards better presenting the project, because this is what I was asked, and not to really say too much of my own philosophy here. The lead partner of this GreenHull project is the Jožef Stefan International Postgraduate School, and of course the enthusiastic people in the school, together with the project partners from the National Institute of Biology, ESOTEC, a company in Slovenia, and two partners from Italy, Gorilla and Comet, put this project together, which was successful now for the second time. Though I have to say the first time the project was much more ambitious, it was much larger in scope, but still having this possibility to really start working and come to an option that can be provided to this sector is very good. So yes, so what these partners really are, we can see immediately that these are the partners that come from different sectors, and their expertise, of course, is different. So it's truly intersectoral and interdisciplinary by what people cover. So the IPS, which is our school, is of course covering chemistry and physics, of course in collaboration with people that are working in nearby research institute where all the research infrastructure is available. But what is the key part that IPS provides is this remotely operated vehicle. So the development of the vehicle that can be navigated from offshore, and then the vehicle goes under the water and then really goes on the bottom of the boats and scrap the boat from the bottom. So many of you are probably familiar with autonomous underwater vehicle. This is something different. This is basically a remotely operated vehicle that we deal here with. National Institute of Biology in Piran is, you know, like a pearl in the marine part of Slovenia. We are very proud of this institute and like to collaborate with them because there are experts in marine biology that we absolutely need in this project. And this is where the home of this knowledge is. ESOTEH comes from, let's say, more eastern part of Slovenia, but they are a very experienced company in environmental technologies and engineering, and they will develop the treatment unit for this scrubbed material that will be taken off the bottom of the boats. And then Kurila, that has experience that especially in this project will provide their expertise, excellent expertise in communication and dissemination, and comment, which comes from mechanical industry cluster that will be also involved in the development of cleaning attachments and dissemination. So let's touch a little bit on the role of the IPS here. As I said already, and I don't want to repeat too much, it's basically the remotely operated vehicle that is going to be further elaborated. Such a vehicle basically exists for completely different purposes, and now will have to be completely remodeled to be able to follow the instructions from onshore. Then, of course, pilot tests of the cleaning process will be something that the IPS will also do, and the IPS is responsible for project management. Now, why underwater hull cleaning is needed? We know that I've already said something about this. Of course, this is a nice picture, which is appealing because the summer is coming and we all want to go out to the sea. We want to feel the sun and the wind and the power of the wind with our sails. But it is, of course, we will have to think about big boats as well. In fact, we have to have a very clean bottom in order to really have efficient movement on the water. So one way by cleaning this, of course, we increase fuel efficiency and therefore decrease the CO2 emission, of course. Lower maintenance costs due to avoiding of regular dry dock cleaning. I mean, this is obvious. I mean, everybody that has a boat knows how expensive it is every second year to take this boat out. Reduction of diffusion of non-indigenous marine species. If, I mean, by proper cleaning, we can, of course, prevent such events to happen. And of course, the reduction of anti-fouling paint releases to the marine environment. Most of this, we put anti-fouling paints because these are toxic substances that prevent animals and all other bio entities in the water to attach to the bottom. So it is toxic by the definition. And this is why we have to clean. But how to clean this, not to make, how to make this more efficient. Biofouling in the marine environment is a process that goes into, let's say, 5 steps, as you can see on this picture. And you also see how does this look under the water. There is all kinds of things that will attach. It's amazing what you will find in the bottom. So bacterial cells settle onto the hard surface. This would be the first step. Then the cells proliferate and secrete slime and forming a biofilm. And then some cells detach, and then protease graze on bacteria. And then the 5th stage will be, of course, enough biofilm to form so that organism can attach. And then when this starts, it's like, like a coronavirus. You have once the sites where this can attach, it will just grow. And that is what makes it unpleasant for the boats when they move. So anti-fouling coatings are something that people, that is something that has to be done. There is no way. There are several technological solutions how to prevent this attachment of all this stuff on the bottom of the boat. And there are some anti-fouling coatings that release is rather low, and then we can have higher release. But these releases from the solid surfaces of the boat to the water will, of course, cause problems we all know that organotin compounds were used for very, very many years. They were very effective. And in some marinas and some, the concentrations were extremely high. And this, of course, is unacceptable. So this is by the law no longer possible to use. And then all the replacements are, of course, biocides that are very toxic. So now mostly what we see, this could be copper compounds, zinc compounds, and a lot of organic compounds that are used today in this anti-fouling paints. Though I have to say, unfortunately, I mean, with regret, that even the market prohibits the use of some of these anti-fouling paints. I can tell you that in the marina waste container, I can still find things that should not be there. So some more enforcement should also be on the monitoring of these things. In water cleaning, of course, there could be active, you can see here the picture. You can have divers that will go with some devices and will scrub off these the stuff from the bottom, but this is rather difficult. This is in practice today. What we would like to do is that the humans are really not going under the water, but that this can be operated remotely. I've said already at the beginning that all of these anti-fouling paints are toxic because they can accumulate in the sediments. We still see, and of course in biota, consequently, especially in benthic organisms, we can find a lot. And we still have a lot of organotin compounds, which are very toxic in the sediments. Though this is less nowadays than it was in the past because the legislation was put in place and we can see that it is effective, but not completely as yet. We will have to be enforced. Most of these anti-fouling paints are toxic to the organisms. And this would be especially a problem in harbors and marinas. And one more thing, which is not only chemistry, we also, by this, we can also have non-indigenous species introduced to harbors and marinas and other open ocean environment. So, well, this is something that needs to be considered. The idea here is that by taking off these things that are in the bottom, that we, all this debris that is then taken off has to be cleaned before it is reintroduced into the water. And this, of course, can be done, and this is the several stage and process by which we then will take off what is needed to be taken off, and then what is remaining to come back to the seawater is the effluent that contains none of these toxic compounds, and so it can safely be discharged into the water, while the solid residues and sludge, of course, is taken away and then treated further. So we will have here, of course, residues that will be solid debris, water, and solid residues after the separation. There will be several methodologies for removal of this debris. It can be mechanical, physical, and chemical, and of course, biological. The methods, of course, there are several methods that are going to be tested. We don't need to go into any detail right now, but there are already several options which have already been proposed, and most of these will be tested, and then we will see what will be the most cost-effective way for removal. So what is really the intention here is that we take away what is hazardous and return the water to the water, so that we don't have, then we minimize this waste that will be obtained after the cleaning of the boats. There were some preliminary field work done already on the sailing boats, 10 meters long, large touristic vessels, and the buoys located in the Gulf of Copper. Then the water and solid samples were taken for preliminary testing. That was done, I think, already before the project was submitted, so that we were able basically to specify better what is going to be done. What was analyzed was water and biofouling, and water and biofouling by the two institutions. All of this work was done. Metals and anion concentrations were measured, metal content was looked at, and then of course some biological measurements were done as well. And what we found that what will be the primary problem, I mean the primary objective is basically to remove copper and zinc and their compounds, which are the main components of the anti-fouling paints that we have seen. So the idea here would be, of course, in water cleaning that will basically reduce any releases of releases of these compounds back to the marine environment. And the overall idea is to do a better work better for the environment, but at the same time will save a lot of money, directly and then indirectly, as I initially said. So this will be all that I have to say for the beginning of this project. And of course, hopefully such webinars will be organized regularly, so that the update of the work be then presented in greater detail also by the partners directly involved in the development of the technology and its application. Thank you very much for your attention.
Thank you very much for a very nice and very clear presentation. So I believe now everybody has a better picture of where the project is going. And we still have time for a short question if somebody has something immediately related to this presentation. Otherwise, there will be time for questions also later, because we have another presentation which relates to this, and it's about biological role of the background of this project and the ecology of biological growth will be presented to us by Dr. Anna Fortic from National Institute of Biology, Marine Biological Station, Tirana.
Hi, hello. Welcome also from my side of the screen. I am coming from the Marine Biology Station in Piran, and just to correct, I am not a doctor yet, I'm a young researcher there, and I will be presenting you the biofouling community from a biologist's perspective, so it's going to be a little bit different. Let me just try to share the screen. Okay. So if we start with some definitions, what actually a biofouling community is a community of marine organisms which form on hard substrates. This is the broad ecological definition, but today we are going to talk about the narrower definition, that is the community of organisms which form on man-made structures and therefore cause certain problems and cause us some pain. To illustrate, let's assume we put this brick somewhere on land, and in 5 months there will be no change at all. Probably some dust will form on it, maybe some pollen. But if we put the same structure underwater, in 5 months we will have quite a colorful community that will form. In this case, it is filled with animals. It is called, they're sessile invertebrates. And this is quite unusual because on land, we are used to animals to moving around, but underwater, they have a special environmental advantage that the water, the seawater, contains the food itself, and it is brought to them by currents of their own making, the ciliary currents and the filtrating apparatus they possess, and also the environmental currents. And these animals are therefore filter feeders. They filter all sorts of organic particles, also phytoplankton, zooplankton, plankton, etc. What is another thing that allows them to use this substrate is the planktonic larvae, which is only a part of their lives in plankton, so it's actually moving in the water column, and later it attaches to a suitable substrate. Here are some examples of these larvae, which we can find in some zooplanktonic samples from the sea. As my predecessor already said, any bare substrate is basically a rare opportunity in the sea. And in a matter of minutes, hours, some biofilm will form on any substrate, which will be composed mainly of bacteria, of some microalgae like diatoms, which secrete some extracellular excretions, and then by that trap some sediments and other particles. Together with some unicellular animals that arrive after these first settlers, are these the first stage of the fouling, the biofouling, is called microfouling, and this is the condition for the larger macrobenthic communities to form. So in this picture, we see this is a photograph of our first sampling, which was being done in this touristic vessel. And here we can see this is just the beginning. This is the microfouling stage of the formation of the fouling community. The next part is when the propagules of macroalgae and also these invertebrate larvae I already talked about come and form these 3D structures we are used to. In water, we can see them everywhere. We look on the piers, on the boats, everywhere. And the formation of these communities is defined by the abiotic conditions, the biotic stressors, the predators, and so on. What I would like to stress here is that the biofouling community is not just algae and oysters. It is formed of a lot of different, taxonomically different groups. Especially, I will be talking about animals today because this is what I specialize in. And these are tunicates. They can be either solitary or colonial bryozoans that form extensive colonies. We have bivalves, as I said, such as mussels, oyster, and so on. Then there are polychaetes of some sorts. They can be either sessile, forming tubes, or others that move around. And there are sponges, hydrozoans, sort of cousins of jellyfish, and barnacles. Of course, there are other animals and plants that can form the biofouling community, and they together with the sessile proportion and the mobile portion, they form complex structures. Even though these communities have important roles in the ecosystems, we know that in man-made structures, they create problems for us. So these photographs just show some of the really familiar scenes from everyday life near the sea, where everything can be quickly covered by the biofouling community. And every single of those roles that are in natural habitats good can be sort of a problem for us, for human, for maritime transport. So one role of this community is habitat forming for other organisms. So big colonial organisms such as bryozoans, they form great masses, which can then provide habitat for more animals, for more algae to arrive, and then later they can host also some mobile species such as crustaceans, other polychaetes, gastropods, and so on. This is the positive. This was the positive thing for the animals, but for us it means creating frictional drag on boat hulls. It also means that these animals, this community can clog pipes in marine industries and also other problems. Another such role in the ecosystem is filter feeding, and some of those animals, they can clear great volumes of seawater. Some solitary tunicates and some bivalves up to 10 to 17 liters of seawater per hour, which is a great volume. And they can regulate in some way microbiological state of the sea, and also they can act sometimes as a eutrophication control. But on the other hand, they also accumulate toxic substances, which is a problem, a common problem. They can be heavy metals, the ones that are found in anti-fouling or others, and also PCBs, microalgal toxins, and others. One of the problems is also that vessels which are harboring dense populations of biofouling community, they also can be a means of transport for species like we know, for non-indigenous species. And this is something I study, and I would like to talk more about to explain to you what is the problem really. A species that has been introduced to a location, area, on a region where it was not found naturally or occurs naturally is called a non-indigenous species. And bioinvasion is the process of introduction of this species by man. It is one of the greatest threats to biodiversity in general. And the Mediterranean Sea is one of the hotspots for this bioinvasion. If we are looking just at the number of non-indigenous species, they present, the estimate is around 3.3, but the number is probably even higher of the whole Mediterranean biodiversity. So 3.3% of all species are non-indigenous. Then the rate of introduction is also a problem because it is increasing with traffic. With every year, this number is bigger and bigger. And another particularity for the Mediterranean Sea is that it has been very fruitful in maritime trade already early in the past. So the early human-mediated introductions are quite common, but are usually not very, we're not aware of them because some species which arrived earlier are now for us part of the natural ecosystems. So shipping is actually a very important introduction pathway for this species. It is the second most important one, right after the corridors, such as Suez Canal. And it is basically, shipping can cause, we can divide it into two vectors. One is ballast waters. We all know that this is a problem, and also really important one is hull fouling. And hull fouling can be also a problem not only for introduction of non-indigenous species to another locations, but also for secondary diffusion throughout the Mediterranean Sea. But the most problematic of all of those things is that if a species which arrives to another region can successfully reproduce in the new environment and have also spread and have negative impacts on biological diversity, on ecosystem functioning, and also on socio and economic values, and also human health sometimes, it can be really problematic. And this species we call invasive alien species. So if I try to tell you a little bit something about the preliminary results which have been made, which have been obtained from the first two samplings in the project GreenHull, I can already tell you that in this sampling, there was not a lot of biofouling material, like microfouling, which I work on. But in this material, we already found two non-indigenous species. One of them was the one on the left, Tricellaria inopinata, which is an arborescent bryozoan originating from Pacific Ocean. And this is a bryozoan that has been recorded in Venice already in 1982, and it has spread rapidly throughout the lagoon, causing some problems in the area. It's probably been introduced here to the Mediterranean Sea with hull fouling or with oyster cultures. And another one, which we dissected also in the samples, was Parantura japonica, a paracarid crustacean, also originating from the Pacific Ocean, from the northwestern to be specific. And it was first recorded in France, in the Atlantic coast of France in 2007. Recently also we found it here in Slovenia, and also the introduction vector for this species is probably hull fouling, or could be oyster cultures as well. Another analysis that has been made during this project was made by my colleague, Dr. Jana France, and she was measuring the chlorophyll A concentration before and after the hull sampling. And the reason why she was doing this is because the chlorophyll A is a green pigment which is present in all green plants. Its concentration is a very good proxy for algal biomass. And even though we did not, in all samples, we did not have a lot of macroalgae or not at all, microalgae are also containing this pigment, and they are among the first organisms that colonize the bare surface, and it's also often found on boat hulls. So this pigment can be a useful tracer if you want to detect biofilm remains in the water after the sampling process. So they did that. They sampled the water before this process and after to see if there's been any release of the so-called biological material that has affected the environment. And some preliminary results from one vessel are already available. And we can see that there has been a slight increase in this pigment in the area. So that would be all from me for now. Thank you for listening. And if you have any questions, let me know.
Thank you very much, Anna, for your very nice presentation of marine biofouling communities ecology. This will be helpful in designing further work in the project and also for understanding of marine ecosystems. May I have one question? You mentioned this problem of bioinvasion. So if you have like this, I mean, animals from other parts of the world attached to the ship, how likely is it that they would be released from the ship into the Adriatic, and how likely is that cleaning would increase this probability?
Well, the whole process, first it would be, it depends on the conditions of the ship, the anti-fouling that is on the ships. So it's a probability that is really hard to estimate how likely is a certain species to travel. But there are some species which are very tolerant to copper-based anti-foulings and which are very, let's say, resilient and can easily be transferred. And if they are opportunistic enough, they can survive the new environment, the new conditions, and it happens a lot. But the probability of to estimate the probability is really hard.
Yes, I understand.
But for the cleaning process, I would say it would be really helpful if we do release all the contain all the material, because already if for example the colony of a bryozoan is already forming larvae, these are very small larvae and they can easily be dispersed into the environment. But it is good to be cleaning these hulls from this point of view, because non-indigenous species really are a big problem.
Yes, exactly. Thank you. We have time for another question. I don't see anybody. Okay, maybe we can do it at the end. So thank you again, Anna, for a very nice presentation. We can clap here below at the bottom menu. And now it is my pleasure to announce the next presentation. The next presentation will be on the interest from an industrial point of view and a cross-border opportunity in the GreenHull project. It will be shared by Mr. Lucio Sabadini from Marine Technology Cluster in Trieste and Riccardo Zanelli from Comet in Pordenone. Please, the floor is yours.
Yeah. Who wants to start, Mr. Sabadini?
Please start.
Oh, I'm ready to start, and
okay.
If possible, I prefer to speak Italian.
Okay, let's see. That means that there is a change in the translation. So the translator from English to Italian would have to switch the channel to English and translate your Italian to English. Okay, thank you.
Allora,
Just a moment. Aspettiamo un momento. There is a technical issue, so.
There is no problem. I continue in English. It's not.
Okay, that would be easiest. Yes, that would be easiest.
It's
okay. Please continue in English.
It's for me, but it's, the project seems very interesting. The project is absolutely very interesting, and my feeling is that the first application should be in the small boats, in the yachting, instead in the shipyard, in the ship. First of all, because the dimension of the ship is quite huge, and I don't know the time the system could be could take to clean a large ship. My idea is could be the way to avoid the anti-biofouling in the naughty, in the yacht, in the boats, and so really boost the greening of marinas, and afterward we should apply it to shipyard, but I think there is a need to understand very well if in the time the ship stops in a port could be cleaned, because I think it's quite impossible to clean a ship during the navigation. So from my point of view, the project is really interesting, but my suggestion is look before to the yacht application and after to the ship application.
Thank you very much for your contribution. I believe we would like to ask Dr. Riccardo Zanelli from Comet Pordenone.
Good afternoon. Good afternoon, everybody.
Good afternoon. Good afternoon. We hear you.
Good afternoon. I can't hear you. Can you hear
maybe
me?
Your channel is. We can hear you. We can hear you.
Okay, fine. Good afternoon, everybody. My name is Riccardo Zanelli, and I'm working as a project manager at Cluster Comet, official partner of the GreenHull project. Well, first of all, let me thank Mr. Sabatini and the cluster he represents, the Maritime Technology Cluster, for being here with us today, for having shown interest into our project. Thanks also to his team that is helping us in disseminating and communicating the project results. I would say that this shows that there's a collaboration going on. There's an existing collaboration between our two organizations, between our two clusters, whose companies are, as you can imagine, inevitably close, linked in a sense. But I'll come back later to this point. Before, I would like to share with you a brief presentation that I've prepared. I'm sorry. Here we are. Okay. Here we are. So, can you see the presentation?
Yes, we see it.
Okay. Okay. So the organization I work for is called Comet, and it is the cluster representing the mechanical and metalworking sector here in Friuli Venezia Giulia. For those of you who never heard about clusters before, well, there is for sure a wide variety of different definitions and types of clusters worldwide. The literature is huge in the sense, but we can describe them as groups of specialized firms, enterprises, oftenly SMEs, that cooperate together with related supporting actors such as universities or technological parks, being part of the same industry or the same supply chain, that they are usually concentrated in a specific geographical area. In other words, clusters are a kind of evolution of the former Italian industrial district model. Cluster Comet and Cluster Mare, Friuli Venezia Giulia, are the outcome of a process driven by our regional administration back in the days, in 2015 more exactly, when Friuli Venezia Giulia decided to recognize by regional law, the so-called Legge Rilancio Impresa, the importance of clusters as tools for the development of the local economy. Cluster Comet in particular is the cluster representing the mechanical sector, representing almost 3,800 enterprises working in mechanics in fields such as components and spare parts production, metal products, machineries and equipment, employing around 57,000 employees totally. Almost 48% of manufacturing companies here in Friuli Venezia Giulia directly operate for the mechanic sector. Long story short, we have the honor to activate projects and initiatives for a sector that is definitely a strategic asset for our regional economy, as you can imagine. There is no doubt that metalworking and the shipbuilding sector are interconnected, are linked, or better, we can say that the two sectors converge into supply chains with a high capacity for growth and innovation. This is particularly true in a region such as ours, such as Friuli Venezia Giulia, which is small, but where we have several companies and firms of excellence, such as Fincantieri, of course, one of the world's largest shipbuilding groups, but also manufacturers of luxury yachts, mega yachts, shipyards, etc., etc. Several of our companies we represent, the companies from Cluster Comet, do directly work for the nautical and naval sector, as you can imagine, since the shipbuilding industry develops the construction of ships and parts of the vessel in steel and other construction materials. I don't know, metal alloys, or titanium or aluminum, and so on. That, of course, our companies work and process. Think about all the local SMEs, the local capable SMEs working in third-party processing for the shipbuilding industry. I don't know, for instance, producing the fire doors for the cruising vessels, no? And also this explains a little bit more our involvement in the GreenHull project, why we decided to participate to this this consortium, and what Cluster Comet then will do in the framework of the GreenHull project. Well, Comet will be responsible together with the research partners for the development of one of the two innovative green technologies solutions for vessel in water cleaning from the biofiling. More precisely, we are going to develop and test the cleaning attachment for an underwater robot. Here in the picture, you have an example of what I'm talking about, of what we have in mind, us partners have in mind. This is in particular an underwater robot for the hull cleaning that is already available in the market. If I'm not wrong, is developed by a French company. The robot will be then equipped with a module, with a cleaning module, integrating a technology solution such as high pressure jets or cavitational jets for the hull cleaning from the biofouling. We are going to develop a similar solution, of course, not on our own, but we're going to develop the prototype together with the research partners, as I said before, and thanks to the support of one of our companies that we will select later on. We believe indeed that their regional metalworking companies that we represent already have the productive capability and the sufficient know-how to start seeing at this one, at the underwater robot construction market, as a new target market. So the GreenHull project could represent an opportunity to them and a way to find new potential clients, to assess to new value chains, to new knowledge flows, and innovation, of course. Consider that the underwater vehicles market, generally speaking, is quite interesting, and that the use of the so-called remotely operated vehicles, the ROVs, for cleaning purposes, but not only, is expected to grow a lot in the next few years. There are already available solutions on the market. We have an example here, especially in Northern European countries, such as Norway and the Netherlands, are already widely using this kind of solutions for different purposes, such as offshore inspection, the cleaning of the hulls, and so on. They are already developing their own underwater hull cleaning robots. From our side, it would be nice, it would be interesting that such solutions might be applied also in our cooperation area, meaning in the Interreg Italian-Slovenian space, and we'll cover why not cleaning operations of the ship hulls in our ports, meaning Venice, Trieste, Piran, and in our marinas. Why not? With this regard, we see in the cross-border sorry, in the cross-border cooperation an opportunity to tackle a common challenge, a common problem of the North Adriatic Sea pollution that knows no boundaries, as Mr. Campostrini said before. But of course, it can be also seen as a business opportunity, since cross-border cooperation brings together research and business communities on both sides of the border. That's very clear. With this in mind, the GreenHull consortium has been built on principles of complementarity, diversity of profiles. Partners such as Joseph Stefan, Corila, Ezotech, NIB, Comet, of course, have high complementarity each other in what they do and in their know-how. So we widely cover both scientific and practical knowledge. In conclusion, I would say that the GreenHull project can help to transform the border into an opportunity in both terms of tackling an environmental challenge, an environmental problem represented by the sea pollution, and in terms of the development, and I would say also further adoption of new technologies, such as this one represented by the unmanned underwater robot. Why not possibly developed here locally by the Slovenian and partners and Italian partners. Thanks for your attention. That's it. I mean, if you have then further question or info, of course, I'm available.
Thank you for a very nice presentation and for the optimistic predictions. So let's hope these predictions will be realized within this project.
Of course.
We still have time for a short question, if there is anything at the moment.
Yeah.
May I ask a question, Milena here?
Of course.
It is very important to consider these aspects in this project, really by the partner like you, as we can see, you see this for the future. I think, in my opinion, also that the opportunities are huge because sailing and the traffic, the marine traffic, is really something that is very important, not only in this part of the Adriatic, but I think we have the whole big span over Croatian line, and talking about, of course, the other parts of the Adriatic coast. But this is obviously a huge opportunity, and if this is successful, it is something very important for this geographical area, because the sailing business becomes really an incredible business in the area if we go southwards more and more. Just
I totally agree with you, Milena. We have also to say that the solution we have in mind will be developed on the basis of good practices deriving from a former European project, which has been developed and tested. It's called UNCOS, if I correctly remember, that test and developed multisensory robotic system, which in the project will be adapted to the needs. So right now, as partners, we are carrying out at the moment a scientific literature analysis in order to find the best solutions and technology to apply. As you can imagine, to clean up the growth of vegetation on ships, you can use different technologies. You can use removal techniques, use brushes in contact with the hull or with the surface. Other methods of removal are rotating blades, for instance, are high pressure water jets and cavitational water jets. Once identified the most suitable technology, but I think that Uroš can explain you better than me, we will adopt it on our robot, on our underwater robot, starting from the one developed during our previous European project that Josef Stefan Institute lead. Am I correct, Uroš?
Exactly, you're perfectly correct. So the idea basically is to upgrade our ROV, which was built in 2011. We will upgrade it with this so-called cleaning attachment that Comet will develop together with IPS, so Josef Stefan International Postgraduate School. And together we will try to find the best solution that will work in water. So here we are basically breaking the ice because this will be a unique solution, and we hope that it will work. So I kindly invite you already here now to our next session, to our next and future webinars, which will be in around a few months. Thank you very much.
Thank you.
Thank you, Uroš, for actually moving us towards a wrap up and conclusions. I believe now it's time for maybe some general comment. Uroš actually summarized the content of this project very nicely now in the last answer. If anybody would like to add something, now is the time. If not, we are going to move to the conclusions. So I would like to thank you all for your participation and your contribution to the success of today's webinar, even at this time so late in the afternoon. A special thanks to all contributors, and particularly to Dr. Uroš Put for excellent organization of today's event, and also for this steady management of the project through all the corona-related and other challenges that have been plenty so far. We will keep you all informed about the progress of the project, and we expect to continue to work together in the implementation of the GreenHull project and its objectives. Your suggestions, questions, and recommendations are always welcome. Thank you, good luck, all the best. Srečno, arrivederci, ci vediamo, se vidimo, srečno.
Thank you, bye-bye.
Ciao,
Bye.
bye.
Bye-bye.
Arrivederci, bye. Thank you
Bye.
very much to everybody.
Thank you. Bye.
Bye.